Welcome to Faith and Science. I'm Dr. John Ashton. I think one of the issues that often atheists and secular scientists bring up against the creation account in the Bible is the problem of the starlight travel, because the Bible clearly talks about the universe being created within the literal 6-day period, 6 literal Earth 24-hour days. When we look at the theology and the language of the ancient Hebrew at the time and the ancient manuscripts, there's no way around this. This is clearly what the Bible tells us happens. And it makes so much sense too in terms of the life requiring ecosystems and those ecosystems having to be created in a short period of time. But what worries a lot of people is the starlight and time effect. If the stars and the sun and the moon were created on the fourth day, how could we see them? Well, of course, the moon and the planets in our solar system are not so much a problem, because like the sunlight, reaches here in quite a short period of time, just a few minutes. And so that's not an issue there. But what about the stars that are millions of light years away? What about even the stars that are sort of only 4 light years away in distance? How could they have been seen in that straight away? So this has often raised an interesting question and a challenge. But one of the things that we need to realise is that when we look at the structure of the universe and what scientists have to do to try and explain the origin of the universe, there's no way that they can get around the issue that there's no natural explanation for how our universe could form according to the known laws of physics. There's no natural explanation. And that's why they have to invoke such energies as dark energy and dark matter. And what are these? These are some source of energy that we don't know anything about, that we can't measure, that sort of expand and stretch the universe out, and dark matter. Some sort of matter that we can't observe, that somehow provided the intense gravitational fields that enabled the early particles of matter that formed from energy, as they claim, to somehow come together. Otherwise, they don't come together. They don't form lumps of matter. They don't fuse and form the higher elements and so forth. So when energy is converted into matter according to Einstein's equation, equals mc squared, where E is the amount of energy produced, is equal to the amount of matter squared, or times itself, multiplied by the speed of light in the units that are appropriate, whatever system of units that you're using, like the metric system and so forth. And so that will give us the amount of energy. But and from the amount of energy, we can back calculate, turn the equation around, and we would have the amount of matter that would be produced by a certain amount of energy. Now, that matter, we know from the law of Baron number that we observe, there's always the same amount of matter and antimatter form. But, of course, we observe mainly matter. We don't observe the antimatter. And secondly, when that matter forms, sort of like a positron is the antimatter of electron, very, very light particle, and the basic sort of element that we have is nitrogen. We have one proton in the nucleus, one electron orbiting, and then if we have deuterium, heavy hydrogen, we have one proton, one neutron in the nucleus, and again one electron orbiting, and so forth. So, but these are gaseous elements. And the next element, helium, with 2 protons in the nucleus and 2 neutrons in the nucleus and 2 electrons orbiting. These, again, are gases with extremely low boiling points, just a few degrees above zero. And so they are present as gases, as in the case of helium, just individual atoms. In the case of hydrogen, and very high temperature, individual atoms, or lower temperature, it can form molecules where you have the two hydrogen atoms together. But these atoms then don't combine. They're not going to coalesce together and form a great mass of hydrogen or helium and create a tremendous amount of heat under pressure to then create fusion and create the higher elements. In order to do that, there has to be some other force, like a gravitational force, or some other matter, dark matter, that would attract it and cause those gases to coalesce. And of course, it's never been detected. But in order for the universe to form, the so-called Big Bang theories and the variations of them require those elements, and they've never been observed. And that dark matter has never been observed. So we need to understand that there's no known explanation for the origin of the universe, just as there's no explanation for how non-living molecules can form a living cell. It's so complex, there's so much design features, there's so many components that have to be just right, and in the quantities of millions of particles just right in the simplest cell to form. So, this is a very serious issue. But people continually raise, okay, but what about this starlight issue? And of course, it becomes a very interesting issue too when we look at the book of Romans. So many Christians are familiar, and atheists, of course, with Genesis chapter 1, where it talks about God created in the 6 literal days. But in Romans chapter 8, as we read from Romans chapter 8, verses 19 onwards, "For the creation waits with eager longing for the revealing of the sons of God. For the creation was subjected to futility, not of its own will, but by the will of him who subjected it in hope, because the creation itself will be set free from its bondage to decay and obtain the glorious liberty of the children of God. We know that the whole creation has been groaning in travail together until now. And not only creation, but we ourselves, who are the first fruits of the Spirit, groan inwardly as we wait for the adoption of sons and the redemption of our bodies." And so what it's talking about here is that the whole of creation was affected by sin, when sin entered the world as Eve was tricked by Satan. Now, this places some interesting concept that if then the whole of creation, so the universe was affected, and then we observe this universe and these stars and that to be so many millions, from years to millions of years to billions of years, light years away, then how could we observe those effects? And, so it's another very interesting time problem. But one of the things that is discussed, I guess, at really high-level physics and in cosmology, and is sort of rarely talked about in sort of ordinary everyday circles, is that special relativity, which is Einstein's theory, which is generally applied in everyday sort of measurements of cosmology and this sort of thing, requires that the speed of light be constant in all directions. Now, this actually results from the choice of eta in a particular equation being a half. And the reason why, and in the equations that are discussed related to this, when eta is chosen to be a half, it simplifies a lot of the equations and produces symmetry and so forth. And so this choice, which was applied in the theory of relativity, bears the name the Einstein synchrony convention, abbreviated ESC. Now, this assumes then that the speed of light is the same in all directions, irrespective of our observer. Now, that actually is a little bit counterintuitive, because if you think about it, if the light is actually travelling away from you, why should it appear to be travelling relative to you at the same speed as if light was travelling directly towards you? And the same if it was at an angle to you. Wouldn't that affect how you observe the speed of light. And so there's another convention called the anisotropic synchrony convention, and this assumes that depending on the angle at which the light is coming to you affects the speed of light. So, for example, the equation involved is that the speed of light is determined from c, which would be the conventional speed of light, divided by 1 minus the cos of theta, where theta is the angle at which the light is coming to you. Now, this equation, which is the ASC equation, as opposed to the Einstein equation, where eta is assumed to be a half, this results in some interesting results. For example, light coming directly towards the observer travels at infinite speed because theta is 0. You're looking directly at, so there's no angle off, so theta is 0. And cos 0 is 1, 1 minus 1 is 0, 0 divided into any number gives the answer infinity. So light then appears to be travelling instantaneously if it is directly towards us. So anything we're looking directly at. Light moving directly away from the observer travels at half the speed of light. Now, when I talk about the speed of light, I guess it could be a little confusing to people with this value c. What we need to remember is that the value c that we measure is actually the average return speed of light. In other words, or the round trip speed of light. In other words, the average speed that light takes if it travels away from us and then back to us. Now, again, so from the equation, assuming that value of c, which is the measured value of c, which is the return trip value of c, then the light travelling away from us is travelling at a half that average speed. And for any light that is moving perpendicular to the incoming direction, in other words, as we're observing light travelling across our path where we have theta is 9 degrees, then that will be travelling at the speed of light. Now, this raises an interesting question, and maybe some of the listeners are asking, well, why should this problem arise? Well, the problem arises from a very interesting aspect of this. In other words, if we're going to measure the speed of light, how do we measure it? We measure it with an observation that travels at the speed of light. So whenever we're measuring the speed of light, we're actually measuring the round trip speed of light. In other words, we've made the assumption that the speed of light is the same in all directions and that the relative speed of light moving towards us and away from us averages out. And so this is, and of course, if you listen to sound, and of course the Doppler effect in sound, we notice a change of note, that when sound is moving away from us, the note is slightly different to when the sound is moving towards us. So this is a very interesting concept that is raised. And essentially what the bottom line that this is saying is that if we assume the ASC position, so the anisotropic synchrony convention, then there's no problem with the biblical timeline, because what we see is instantly happening. This is what is happening now. And this is something that has always fascinated me, because when we look out at the universe, it's sort of the events that are happening, the star formation that is happening, all this sort of thing that we observe. It's almost as if it's on our timescale. It's designed for us to be observed. we're observing this. These events are happening, and they happen on our sort of timescale as well. That's why we can observe them. We can observe these changes. We only get into the distance problem if we assume the assumption that the speed of light is the same in all directions. And it's an interesting book that deals with this. Is if anyone's interested, it's just been published 2018, and it's called The Physics of Einstein, Black Holes, Time Travel, Distant Starlight, E equals mc squared. And it's by an astrophysicist, the guy with a PhD in astrophysics, called Jason Lisle, Lisle. So I'll just go through that again. The book is called The Physics of Einstein, Black Holes, Time Travel, Distant Starlight, E equals mc squared, by Jason Lisle, Lisle. Now it's interesting, Lisle actually cites quite a bit of the evidence that deals with some of the common objections to the ASC assumption that light is not the same in all directions, and shows that they fail to show that this assumption, this logical assumption, is false. It's interesting, of course, that Maxwell's equations, and I'm a big fan of Maxwell. He was a creationist. His equations of electromagnetism showed the one-way speed of light must be the same in all directions as they would arrive, but they would arrive within a closed system. And the thing is that as the equations are solved, of course, they are solved within the theory now of special relativity. But if Maxwell equations are written in the more generalised form, where Eta or Epsilon rather can take any value, then we find the propagation speed of light depends on the direction of propagation. And so Maxwell's equations, in actual fact, can't be used as an argument against the proposal that light is the speed of light is not the same in all directions. So it's a very interesting issue, but essentially what it shows is that when we delve into these higher areas of physics and cosmology, the evidence supporting the biblical account is actually growing. And it actually, when we look at the solutions of some of these things, it solves some of the issues related, for example, if we remember the problems that sin introduced for the entire universe as a result of Eve being tricked by Satan and sin being introduced. And as Paul points out, as God revealed to him, the whole of creation has been affected. So it's really good that, scientists such as Lisle are writing in this area and accumulating and presenting the evidence from physics that we have now that is actually supporting the biblical creation account. Some of the there's been other books that have been written in this area. Another author that is well worth looking up is John Hartnett, who was a research professor of physics at the University of Western Australia, I think, or Curtin University. I think just recently he's moved to the University of Adelaide. But he is a good one to actually look. He's written some popular books, but also in the Journal of Creation, and which is a technical journal. he's written some quite interesting articles looking at the evidence that we have from astronomy for creation. I should also mention too, I suppose, the work back in 1970 of John Winnie, and he was the one who actually showed that the measurable effects of special relativity as they're applied in physics today, so that's Einstein's theory of special relativity, which is the simplest version one as opposed to general relativity. All these measurable effects depend on the round-trip speed of light and not the one-way speed of light. And so whatever the one-way speed of light is, it actually has no effect on the measurable physics of the universe. The one-way speed only affects how we define simultaneous, and thus how we timestamp various events. And his papers, actually, for those who are interested, if I can look them up there, they were published in the Philosophy of Science, that's a journal, the Philosophy of Science, back in 1970. And the title of the paper was Special Relativity Without One-Way Velocity Assumptions. So part one, so that was published in Philosophy of Science, volume 37, pages 81 to 99 in 1970. And the second part, Special Relativity Without One-Way Velocity Assumptions, part two, published in Philosophy of Science, in volume 37, number 2, pages 223 to 238. So that was 1970. So he was a philosopher that pointed out these problems because all the measurements of the speed of light have been based on the return trip speed. So there's the average speed over that time. And this is, quite a fascinating situation. Of course, for those that are interested, the other one is the problem of locality as predicted by quantum mechanics. So you've got Einstein's relativity theories, and then you've got quantum mechanics. Now, quantum mechanics, of course, predicts interactions faster than the speed of light, and these are related to locality, and these originally arose from the Einstein EPR, Einstein-Podolsky-Rosen experiment. I think it was written up just before the war, about 1939, I think, and this was one of Einstein with a couple of his students there at Princeton were challenging, the validity of quantum mechanics, but essentially it challenges that if you have an atom where you have spin-paired electrons, quantum mechanics predicts that the total, they're coupled in terms of angular momentum, and they must always retain that coupling. And different equations were worked out related to this, such as Bell's inequality and so forth. And then some experimental protocols. An experiment was designed to actually test Bell's inequality and the EPR thought experiment. And Alain Aspect, a French physicist, carried out the experiments. I think in the early 1980s, the date 1983 comes to mind, that essentially showed, and what they were able to do was they were able to rotate light, polarised light, and separate two beams, have them travelling in opposite directions, and show that when they rotated and affected the polarity of one light beam that was coupled from, because the two light beams, what they did was they excited a calcium atom which has two spin-paired electrons in the outer shell, and using tourmaline, which is a fascinating crystal that actually separates polarised light. And so normally when you, and I've spoken about this before, normally when you have a ray of light going through a crystal or glass or anything, it sort of bends the ray of light, refracts it. Now, in certain crystals, of course, such as tourmaline, you get two rays formed. And what happens is that light is separated according to its polarisation. So light waves, the electric fields and the magnetic fields, vibrate in planes. And random light from the sunlight, the planes are in all directions, full 360 degrees, all combinations. But if we reflect light or pass it through a polarizer, what happens is we line up all those waves of vibration of the electric fields in one direction, and that becomes polarised light. And like the principle of polarised sunglasses, when light is reflected off a surface, it tends to be polarised in one direction. And so polarised sunglasses work by not allowing reflected light polarisation to penetrate, and so they actually physically block out reflected light. That's why they're very good in the snow or on water. So again, they were able to pass the light through tourmaline and separate the two types of polarised light, send them in different directions, affect one, rotate one, and instantaneously, faster than the speed of light, the other one rotated. So there's some fascinating things out there in terms of physics that are all pointing to an amazing system that our Creator set up, and how we can instantaneously have and understand what is happening in the universe. So I think this is really, really fascinating, and this is one of the assumptions that's still being debated in science. Is the speed of light the same in all directions? And as we can see, if we assume the ASC convention, that it beautifully explains the biblical account, and there's no problem with the passages such as in Romans. You've been listening to Faith in Science, and remember, you can Google 3abnaustralia.org.au and click on the listen button and go over these and many other programs. I'm Dr. John Ashton. Have a great day.
You've been listening to a production of 3ABN Australia Radio.